Okay, good morning, everybody. So for today's lecture, we're going to proceed with lecture 17, which will be covering the following topics. Number one, we're going to have a brief introduction, a brief understanding on the filters. Number two, we're going to see the first type of filters, which is a low-pass filters, and number three, the second type of filters, which is a high-pass filters. Okay, in order for us to understand well on lecture 17, a prerequisite of lecture 16, which is on a board plot or board diagram, is a must. So before we proceed to lecture 17, make sure that you have good understanding on how to plot a board diagram, yeah? Okay. Sorry, this is a revision on the filters. So basically, if you can recall back, we have learned about the filters in chapter 3 when we learn about the Fourier transform, yeah? So for transform, one of the application that we have learned is on the filters, yeah? Okay, going back to this diagram, if we have a systems of HS, we have the input of AS and the output of BS, okay? So we can see that the transfer function or the frequency response of the system is simply a ratio of the output, which is a BS, over the AS of the input. Okay, this is how you can calculate the transfer function or the frequency response of the system by simply find a ratio between the output and the input. Okay, so in our system, in this chapter, the systems that we are going to concentrate is a filter, yeah? Okay, so there are two types of filters. The first type is what we call as a passive filters. So the passive filters is named because of the passive component used, yeah, in its structure. So the components used are the resistor R, the inductor L, and the capacitor C, right? So and the other type of filters is what we call as the active filters. And the active filters is contain the components of the op-amp, yeah, operational amplifier, and the transistors. Okay, so I believe that the active filters will be learned in your electronic subjects. Okay, so our interest in this chapter, this topic, is on the passive filters. The passive filters contains the component of R, L, and C. Okay, this will be the layout, the block diagram of our system, where we have the input, and we have the systems, in our case is the filters, having the R, L, and C components, and then we have the output. Okay, so in our case, we are going to apply the Laplace transform, yeah, which can be further used in investigating the filters behavior, yeah. So our main tools in order to analyze the filters is the Laplace transform, yeah. Okay, so the passive filters can be further divided according to this filter range ability, where you are going to learn about the low pass filter, LPF. Number 2 is the high pass filter, and number 3 is a band pass, and number 4 is a band reject, yeah. Okay, so in our case, we are going to cover only the low pass filter and the high pass filters, because these filters are the first order type. We can find the first order type in low pass and high pass filter. Okay, the band pass filters and band reject filters. These filters, the minimum order that it can have is a second order. Okay, so these filters type, the band pass and band reject, you can learn it further in lecture 18, yeah. So I've put lecture 18 in the e-learning, which generally covered the theoretical parts of the band pass filter and the band reject filters, but we are not going to cover that in our lectures. Yeah, so I left this lecture 18 to be learned on your own. Yeah, so our emphasis will be only on low pass filter and the high pass filters, because the reasons why is we are going to cover only the first order type of the filters. Yeah, so the first order types for the filters can be obtained from in the low pass and the high pass filters. Yeah, so that should be the minimum order that low pass and high pass filter can have. Okay, so the filter is basically identified by its frequency response plot. Yeah, and I believe that the frequency response plot has been learned in lecture 16. Yeah, which is basically a Bode plot. Yeah, and the Bode plot consists of two types, the magnitude plot and also the phase angle plot. Yeah, so just to make it clear that in this lecture we're going to actually repeating the topics that we have learned in lecture 16, in which we are going to obtain the transfer function of the filters, and from the transfer function we are going to sketch the Bode diagram, and from the Bode diagram obtained we can then deduce, we can then know what is the filter type. Okay, so this will be the task that we're going to do in this lecture 17. Previously, we have understand the Bode diagram. So in this lecture, we are going to obtain the transfer function, from the given electrical circuit, which contains the R, L, and C components. And from this transfer function, we're going to sketch the Bode diagram, and from the sketch Bode diagram, we're going to determine the filter type. Yeah. Okay. So these are the tasks that we're going to learn in this lecture 17. Okay. So basically, the Bode plot can be obtained from the transfer function, in which the transfer function basically, or we have discussed this in the very early part of this lecture, which is the ratio of the output and the input. Yeah, so that should be the transfer function. Okay, so as for the first exercise, we're going to see how to calculate or how to obtain the transfer function if we have this circuit. So the circuit that we have in this example consists of two components only, which are the resistor R of 2 ohm and the capacitor C of 50 microfarad. Yeah. So the question is, we need to obtain the transfer function. Yeah, the transfer function should be in Laplace transform, which is the V naught S over the VIS. So V naught S basically is the output voltage across the capacitor over the input voltage of VIS. So how to calculate the transfer function for this example? So let's have a look at the solution for these questions. Yeah. So what we have to do, basically, we need to transform the circuit, into the S domain. So this has been learned in lecture 15, okay, on the Laplace transformation of the circuit. Okay, so we shall assume that the initial value of the voltage for the capacitor is 0. Okay, so the transformation will look like this. So we have the VIS transformation of the input voltage. Resistor 2 ohm will be 2 ohm. There's no changes on the resistor value. Whereas for the capacitor of 50 microfarad in time domain, in frequency domain, it will be 1 over SC. Yeah, 1 over SC, and that will give us 20 over S as the capacitor in the S domain. Okay, so it should be the circuit which has been transformed into the S domain. Okay, so by using a voltage division rule, voltage division rule, we can say that the input voltage over 2 plus 20 over S, which is the total impedance of the circuit, shall be equals to V naught S divided by impedance of the capacitor. Okay, so this is the based on the voltage division rule. So from this relationship, we can then calculate the transfer function, which is the ratio of the output voltage over the input voltage. So HS will be V naught S over the VIS will be then equals to this calculation, and end up going to have 10 over S plus 10. So this is a transfer function of your filter. Transfer function of the filter. Okay, so hopefully by this example, you can then understand how can we calculate a transfer function for a given electrical circuit. Okay, so the next task that we're going to see in the next lectures, or the second part of lecture 17 after this, will be from this transfer function that we have, we're going to sketch the board diagram. Okay, and from the sketchboard diagram, we are going to determine the filter type. Okay, so that should be the main task of lecture 17. You got the circuit, you obtain the transfer function. From the transfer function, you sketch the board diagram, and from the board diagram, you can then determine the filter type. Okay, so I'm going to stop here, and we're going to proceed with part 2 of lecture 17, which will be covering the first type of the filter, which is a low pass filter. Okay, so thank you very much. See you after this.